Hello! In this video, we're going to be working through the Pre-Calc A Summer Assignment numbers 19 through 27. For each of these problems, we are going to be solving quadratics by factoring. Factoring is an important skill that's going to be with us through all of this year and next year. Please make sure you review each of these problems, and if you have any questions, you ask your teacher about them. Before we get started, let's recall a few important types of factoring we will need for these problems. First, the GCF. Always our first step is to find and, if possible, take out the greatest common factor from all of our terms. Sometimes referred to as basic or easy factoring is when a equals 1. This is used for problems that look like ax squared plus bx plus c equals 0. If a equals 1, you can look for factors of c that add up to b. When a is not equal to 1, you need to use the AC method. Here you can multiply a times c and then break down your middle b terms that you can factor by grouping. The difference of squares is an important pattern that you will need to remember. Factor by grouping you use when you have 4 terms. You're going to group the first 2 and the last 2 and then find the greatest common factor of each. All of these problems today are going to be using the zero product property. The zero product property says that you can take each factor and set it equal to 0 to find solutions. Let's get started with number 19. Here we want to solve by factoring 2x cubed minus 6x equals 0. Remember, our first step is always going to be to try to simplify by factoring out a greatest common factor. Notice that 2 and 6 are both even numbers, so they are both divisible by 2, and both of our terms have an x in them. So we can factor out our greatest common factor, which in this case is going to be 2x. If we pull a 2x to the front, that means we're going to divide each term by 2x and see what we have left over. In our first term, we would still have x squared, and in our second term, we would still have 3. You can check your work by redistributing the 2x through x squared minus 3 and confirming that you get back to your original problem. Now that we have two factors, 2x and x squared minus 3, we can go ahead and use that zero product property that says we can set each factor equal to 0. So I'm going to break my problem into 2x equals 0 and x squared minus 3 equals 0. Now I can solve here by dividing by 2. And I get one solution that says x equals 0. For my second equation, I'm going to start by adding 3 to both sides, so I have x squared equals 3. And now I can solve by taking the square root of both sides of my equation. So I get x equals the square root of 3. But remember, there are two possibilities there. I would have a positive square root of 3 and a negative square root of 3. So here I got 3 solutions, x equals 0, x equals positive square root of 3, and x equals negative square root of 3. Remember, we can use the fundamental theorem of algebra to check that we have the correct number of solutions. The fundamental theorem of algebra says that a degree 3 polynomial should have 3 total solutions as long as we count any repeats that many times. For number 20, we want to solve by factoring, where our quadratic is 36x squared minus 108x plus 81, and it's set equal to 0. Again, our first step, we always want to start by looking for a greatest common factor. Looking at our numbers, 36, 108, and 81, I recognize that these are all divisible by 9, so I'm going to go ahead and factor a 9 to the outside of my equation. Remember, when you're factoring out your GCF, you want to divide each term by 9, or by your GCF. So 36 divided by 9 would give us 4, and since we're not taking any kind of x or variable out with our GCF, our variables are going to stay the same. X squared minus 108 divided by 9 is going to give us 12, and we still have that x, plus 81 divided by 9 is going to give us 9, and our equation is still set equal to 0. Now our numbers are a little bit more manageable, where we need to factor 4x squared minus 12x plus 9. Notice that we still have a term, or a coefficient for our a value, different than 1. So here we're going to need to use AC method. Remember, for the AC method, you want to start by multiplying a times c. I'm going to do my work over here. So A times C means I'm going to multiply 4 times 9 gives me 36. Notice 4 and 9 are both positive. That makes it a little bit easier. Now I'm going to think about all of my factors of 36. These are steps that you're able to skip in your head, but I'm going to go through all of them for this example. So to get 36, I can do 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. Of these factors, I'm looking for a possibility that would add up to 12, and more specifically, negative 12. So 6 and 6 are both going to add up to 12. Because I need it to be a negative 12, I would need both of these to be negative. I can confirm that they're still going to multiply to a positive 36. Now I can go ahead and break my b term into those two factors. So I still have 9 on the outside. Then I have 4x squared. But now I'm going to take this negative 12x and actually break it into minus 6x, minus 6x, and then I'm going to keep going with my problem, plus 9 equals 0. Now that we've created 4 terms, we can go ahead and continue factoring by grouping. Remember, to factor by grouping, you group your first 2 terms, and you group your second 2 terms, and you factor out the greatest common factor of each. So keeping my 9 on the outside here, the greatest common factor of 4x squared and negative 6x would be 2x, and what's left on the inside would be 2x minus 3. And then same thing, the greatest common factor of negative 6x and positive 9 would be a negative 3, and what's left on the inside would be 2x minus 3, and we can set that equal to 0. Now factoring by grouping, notice that inside our parentheses, these two things are the same. That should happen. If it doesn't, something has gone wrong. So we can keep our 9 on the outside. We can actually bring this factor down to x minus 3. And then our second set of parentheses is going to have whatever was left over, this 2x minus 3. Here it just so happens that that is the same. And then we can set this equal to 0. Now we can divide by 9 here to move it to the other side. And 0 divided by 9 is still just 0. Just going to go ahead and write that as 0. Now we can go ahead and use our zero product property, and we can set each factor equal to 0. Here they're the same, so we have 2x minus 3 equals 0, and 2x minus 3 equals 0. Solving for x in both cases, we would get x equals 3/2. So we get the same number twice. Remember that fundamental theorem of algebra said we would get 2 solutions. Here we only have 1, but it does happen twice, or it has a multiplicity of 2, so that still does satisfy that fundamental theorem of algebra. In number 21, notice that a big difference is that our equation is not set equal to 0. Here we have x squared minus 5x equals negative 6. The first thing we want to do is actually add our 6 to both sides so that we create an equation that's equal to 0. So we have x squared minus 5x plus 6 equals 0. Now we can factor this quadratic, and notice that our a term is equal to 1. So here we're just going to look for factors of c that add up to b. So we can go ahead and set up our 2 sets of parentheses and fill in our x's. Here we're looking for factors of positive 6 that add up to negative 5. Now let's just remember factors of 6 are just 1 times 6, or we can have negative 1 and negative 6, 2 times 3, or negative 2 and negative 3. Now of these, the ones that are going to add up to negative 5 are going to be negative 2 and negative 3. We can go ahead and fill in our two factors. Now we've factored this to be x minus 2, x minus 3. Zero product property says we can set each one equal to 0. X minus 2 equals 0, and x minus 3 equals 0. Solving both equations, we get x equals 2 and x equals 3. Number 22 is very similar. Again, we have an equation that's not set equal to 0, so we're going to add 2 to both sides before we really get started. So we've created the equation 3x squared minus 5x plus 2 equals 0. Now, different than number 21, here we actually do have an a value that's different than 1, so we want to go ahead and use AC method. AC method says we're going to multiply 3 times 2, and we're going to get 6 again, so this work we did earlier is actually going to come in helpful again. Again, we want to look for factors that are going to add to our b term, or -5. Again, that exact same work from earlier. We can rewrite our problem, but this time we're actually going to split that -5x into those two terms. I'm going to split this into 3x squared. I'm going to write minus 3x minus 2x plus 2 equals 0. Now that I have 4 terms, I can go ahead and factor by grouping my first 2 and my last 2. Taking out the greatest common factor of 3x squared and -3x, I can actually take out a 3x, and what's left would be x minus 1. In my second grouping, I have -2x and a +2, so I'm going to go ahead and take out a -2, and what I'm left with is x minus 1, and this is set equal to 0. Notice that my two parentheses are the same. That should happen. I'm going to write that as my first factor, x minus 1, and then anything that was left over, this 3x minus 2, is going to go inside my second factor. So we've now taken our equation 3x squared minus 5x plus 2 and factored it into x minus 1, 3x minus 2. Zero product property says we can set each factor equal to 0. So we have x minus 1 equals 0 and 3x minus 2 equals 0. Solving our first equation by adding 1, we get x equals 1. Solving our second equation by adding 2 and dividing by 3, we get x equals 2/3. In number 23, we want to solve 12 plus 5x minus 2x squared equals 0. Since the x squared term is negative, we want to move all of these terms to the other side. So we're going to be adding 2x squared, subtracting 5x, and subtracting 12 on both sides. So we're changing the problem to say 0 equals 2x squared minus 5x minus 12. This is going to be easier for us now because our x squared term is no longer negative. We do, however, have to use AC method here. So here we're going to multiply 2 times -12, and we get -24. Now we want to think about factors of -24. We could have 1 times -24, and we could also have -1 times 24. We could have 2 times -12 or -2 times +12. We could have 3 times -8 or -3 times +8. We could have 4 times -6 or -4 times +6. I listed those all out. If you can find these factors in your head and move a little bit faster, that's totally fine. You don't have to write all of the steps. Now, AC method says we're looking for factors of AC that add up to B, so -5. Looking at my choices, I'm going to go ahead and choose 3 and -8 because those are going to add to -5. So now, just like we did before, we're going to split our middle term, that -5x. I'm going to keep my 0 on the left-hand side, just for fun. I'm going to rewrite my problem as 2x squared. Now I'm going to split my -5x into 3 and -8. I'm just going to write them backwards, minus 8x plus 3x minus 12. Now that I have 4 terms, I can go ahead and factor by grouping. Taking my greatest common factor of my first grouping, so 2x squared and -8x, my greatest common factor is going to be 2x, and I'm left with x minus 4. And in my second grouping, 3x and -12, my greatest common factor is going to be a +3, and I am left with x minus 4. Parentheses are the same, that should always happen. I'm left with 0 equals x minus 4, and then the leftovers, 2x plus 3, go in my second grouping. Now that I've factored my quadratic, I can go ahead and use the zero product property to set each factor equal to 0. So I have x minus 4 equals 0, and 2x plus 3 equals 0. Solving my first equation, I get x equals 4, and my second equation, we get x equals negative 3 halves. Okay, for number 24, we want to factor to solve 6x cubed minus 2x plus 3x squared minus 1 equals 0. Because we have 4 terms, our automatic instinct is to use factor by grouping, but we just want to take note that the reason we're allowed to use grouping here is because the ratio of the first 2 terms, so 6 to negative 2, is equal to the ratio of the last 2 terms, 3 to negative 1. And a really fast way to just check that is just to cross multiply. You get negative 6 on both sides. So you know that those ratios are equal, so we can go ahead and use grouping, just like we had been after the AC method in a couple of the last problems. So we're going to go ahead and group by grouping our first 2 terms and our second 2 terms together. Taking out the GCF of the first 2 terms, 6x cubed and 2x, we can actually take a 2x out, and we're left with a 3x squared minus 1. And then in our second 2 terms, 3x squared and negative 1, they actually don't have anything significant in common, so their greatest common factor there is actually going to be a positive 1. So we can take out a positive 1, and then we're left with 3x squared minus 1. Now, just like we saw before, our parentheses are the same, 3x squared minus 1, and then our leftovers, 2x plus 1, fill in our second set of parentheses. Oops. Now we can go ahead and use our zero product property to set each factor equal to 0. 3x squared minus 1 equals 0, and 2x plus 1 equals 0. Now when we solve 3x squared minus 1, we're going to start by adding 1 to both sides. So we get 3x squared equals 1. And then we would divide by 3, so we get x squared equals 1/3. Now we can solve this using square root. So taking the square root of both sides, we would get x equals, because we're taking a square root here, we would get plus or minus the square root of 1/3. Now remember, you can break that up to be plus or minus the square root of 1 over the square root of 3. The square root of 1 we know is just 1. So our answer right now would be plus or minus 1 over the square root of 3. But remember from earlier, big problem, not allowed to have a radical in the denominator, so we're going to go ahead and rationalize. We're going to do that by multiplying by root 3 over root 3. So this would become 1 times root 3 is just the square root of 3, over root 3 times root 3 would be the square root of 9, or 3. So this equation, 3x squared minus 1, gives us the solution x equals plus or minus root 3 over 3. And it's really important that we recognize how to simplify that. So there's 2 answers. Remember that fundamental theorem of algebra says because we have a degree 3 polynomial, we should get 3. We can also solve this second equation by subtracting 1 and dividing by 2, and we get x equals negative 1/2. So your 3 solutions would be positive root 3 over 3, negative root 3 over 3, and negative 1/2. Okay, for 25 and 26, both of these problems, we need to be able to recognize the special pattern, the difference of squares. So on this post-it, we have the formula for you, a squared minus b squared. So if you can recognize what's being squared in your first term and what's being squared in your second term, then you can factor it into a minus b, a plus b. So if we look at 25, we have x squared minus 25. So in order to follow this pattern, we actually want to start by rewriting this as x squared minus 5 squared equals 0, because now we can very easily identify x as a and 5 as b. So now we can just go ahead and fill in our pattern as a minus b, a plus b, and we can factor this as x minus 5, x plus 5 equals 0. Now that the factoring is done, we can use zero product property and set each one equal to 0. Going ahead and solving, we get x equals 5 and x equals -5. Notice these are the same answers we would get if we solved using square roots, but we just want to take note that the directions were to solve by factoring so we can practice this difference of squares skill. Looking at 26, now we have a little bit more complex of a problem. Here we have 49x squared minus 1. Just like we did in the first step of 25, we want to start by rewriting this so that we can identify our a value and our b value. Because 49 is 7 squared, we can go ahead and rewrite our first term as 7x squared minus, and since 1 squared is just 1, we can write this as 1 squared. Now we can identify our a value as 7x and our b value as 1. Following our pattern, we can factor this into 7x minus 1, 7x plus 1 equals 0. Zero product property says set each factor equal to 0. 7x minus 1 equals 0 and 7x plus 1 equals 0. Solving each equation, we get x equals 1/7 and x equals -1/7. Okay, for 27, we have 4x squared minus 8x equals 32. First, notice that this is not set equal to 0, so the first thing we want to do is actually subtract our 32 over to the left-hand side. So the problem we want to be working with here is 4x squared minus 8x minus 32 equals 0. Now 4, 8, 32 are all kind of big numbers, so recognizing that they're all divisible by 4, we first want to take our greatest common factor out before we try any of our other factoring methods. So pulling a 4 to the outside, we're left with x squared minus 2x minus 8 equals 0. From here, we can keep our 4 on the outside, and we just want to use our basic factoring method here, where a is equal to 1. We can fill in our x's, and here we're looking for factors of -8 that add up to -2. So to get -8, you could do 1 times -8 or -1 times 8. You could do 2 times -4 or -2 times +4. And of these, the combination that's going to add up to -2 is going to be a +2 and a -4, so we can go ahead and fill those in. Dividing by 4 on both sides, we're left with the equation x plus 2 times x minus 4 equals 0, since 0 divided by anything is still just 0. Zero product property says we can go ahead and set x plus 2 equal to 0 and x minus 4 equal to 0. And our final answers here are going to be x equals -2 and x equals a +4. Great job with these. Remember that factoring is an important concept that we're going to be using throughout this whole year in pre-calc and that you'll be using whenever you take calculus. So if you have any further questions about these factoring topics or you want to go over any of these problems again, please just feel free to reach out to your teacher.